Hi dears, this is Raji. In this video, we are going to learn the reaction of ammonia with metal oxide. So, you will have to learn the reducing property of ammonia, and related to that, you will have to learn two reactions. Mainly, ammonia with chlorine and ammonia with metal oxide. How ammonia will be reacting with chlorine, we have already discussed in that part 5 of the chapter ammonia. So, you can just go through that video if you haven't watched that. I have discussed some important questions related to that and observations of the reactions also we have seen in that. You can just check it. Okay, now let's see what will be the reaction of metal oxide. So especially copper oxide, how it will be reacting with ammonia. Then related to that, again they will ask you lead oxide, how it will be reacting with ammonia. So let's see that. What will be the product obtained when ammonia reacts with metal oxide? As an example, we have taken copper oxide. Okay, so copper oxide, we are taking it in a glass tube and we are heating that. Okay, over hot copper oxide, we are passing dry ammonia gas. Okay, so what will be the product obtained? First, we need to predict the product of the reaction and then we will speak about it. Okay, write along with me. Ammonia, okay, is passed over hot copper oxide. Okay, so we don't want to by heart the product. Okay, there is an easy method to predict the product of the reaction. What is that? In the previous video also we discussed that. Okay, what is that? Ammonia is a reducing agent. We know that a reducing agent is a substance which will be forcibly giving some hydrogen to somebody. We know that. Okay, if hydrogen is given to copper oxide forcibly by ammonia, see, oxygen will go and capture that hydrogen. Correct, no? Okay, so what will be one product obtained? Definitely it will be water. Correct, no? Okay, so from ammonia, hydrogen is going along with oxygen. Then what is remaining over here? Another product obtained will be nitrogen. Okay, then from copper oxide, see, oxygen is going along with hydrogen. Then what is remaining? Another product obtained will be copper. Easy, no? So try to predict the product of the reaction in the same way so that you will never forget it. Okay, instead of by hearting that, this is the easy method. Okay, now try to balance it. Right hand side 2 nitrogen, here only 1 nitrogen, so we will put a 2 in front of that. Now how many hydrogens here? Okay, total 3 2s are 6 and here only 2 are there, so I am putting a 3 over here. How many oxygens are there on the right hand side? 3 oxygen. Okay, now here copper oxide, I am putting a 3 in front of it. Now what happened to copper? Here it is 3 and here it is only 1, so that we are putting a 3 over here. Clear, no? Okay, so this time we are so happy. What is the reason? We balance the chemical reaction so easily and we could predict the product of the reaction also. Got it, no? Okay, so one part is over. So then next one. Okay, next point they used to ask. Commonly from this concept is that what will be the observation of the reaction? Okay, observation of the reaction. Write along with me. So see, in order to answer this kind of observation questions, you should have an idea about the color of certain compounds. Okay, so here we have taken copper oxide. What is the color of copper oxide? See, I have kept a picture over here. Okay, copper oxide is black in color, right? No? Okay, and after passing ammonia gas over it, what will happen to copper oxide? It will be turning into copper. You know the color of copper wire, right? No, same color, but we will say that color as reddish brown. Correct, no? Okay, so what will be the observation of the reaction? If they are asking, you can say that a black colored substance will be turning into reddish brown. Look at this picture one more time. Okay, see, copper is formed inside the test tube. We agree that, but in addition to that, we have some more setup also. Okay, in the picture we have a U tube and which in turn is immersed in cold water, and there is another setup for collecting nitrogen gas also. What is happening over here? Remember, when nitrogen and water is forming, both are gases, we know that. Okay, water also, it will be in the gaseous form. So both these gaseous products will be fed into this U tube, which in turn will be immersed in cold water. Okay, so at that time what will happen? Water vapor will be turning into liquid water. Got it? Whereas nitrogen, yeah, nothing will happen to that because it is very less soluble in water. So what will happen? It will go up and will be getting collected over here. Nitrogen gas will be collected over here. Got it? No? Okay. Now see that again they will ask you one more question. Okay, yeah. So the liquid we are obtaining in this U tube. Okay, yeah. That is nothing but yeah water we are telling. Okay, yeah. How can you prove that whether that liquid is water or not? You can collect that liquid and you can pour it on anhydrous copper sulfate. If you are pouring it on anhydrous copper sulfate, you will be getting hydrated copper sulfate. What is the color of hydrated copper sulfate? It will be blue in color. And anhydrous copper sulfate, it doesn't have any color. So for some children, they won't be getting the idea. Okay, what do you mean by this anhydrous copper sulfate? And what do you mean by this hydrated copper sulfate? For those children, I have kept one more picture in the next page. You can just see that. Now see this picture. We have taken some copper sulfate solution. What is the color of copper sulfate solution? It is blue in color. We are heating this copper sulfate solution. So what will happen? Yeah, some amount of water will be going out of the solution or it is evaporating, and the solution of copper sulfate after some time it will become a saturated solution. Okay, yeah. After making the solution saturated, we are going to cool it down. Okay, yeah. Pour it into another tray. As you can see in the picture, what will happen? Yeah, you can see that copper sulfate crystals will be coming out of the solution. Right now, what is that process known as? Yeah, the process is known as crystallization. Okay, yeah. We are interested in the formula of copper sulfate crystals formed. Okay, yeah. See this one. What will be the formula of copper sulfate? Write along with me. Okay, yeah. That is CuSO4 dot 5H2O we will write. Okay, yeah. What is this 5H2O? That is known as water of crystallization. Okay, yeah. Water of crystallization we will say. Okay, yeah. So what is this water of crystallization? Whenever a salt is crystallizing out from a saturated solution, some amount of water will be associated with it. Okay, yeah. The number of molecules of water that is associated with that salt is known as water of crystallization. Got it? Okay, yeah. Now, this 5 molecules of water that is present in copper sulfate. Okay, yeah. That is responsible for the color of that salt also, and it will give that copper sulfate a crystalline nature also. Write it. Yeah. What all things it is responsible for? It is responsible for the color also and the crystalline nature also. Got it? No? Okay, yeah. Crystalline nature means, yeah, one piece you can pick it up. Okay, yeah, like that. I'll tell you an example. Okay, you might have seen some romantic movies. Okay, yeah. In that, the hero will be telling the heroine. Okay, yeah. Oh, without you, yeah, my life is colorless. Correct? No? Okay, yeah. So if the heroine is there along with the hero, his life will be, yeah, colorful, he is telling. Okay, yeah. So you can remember that copper sulfate here is the hero. Right? No? Okay, yeah. Whereas water is the heroine. Okay, yeah. So if water is there along with copper sulfate, it will be having a color also, crystalline nature also. And if water is not present, that is heroine is not there along with the hero, what will happen? Yeah. So hero will be completely desperate. Correct? No? Okay, yeah. His life is colorless now. Okay, if you have anhydrous copper sulfate, the copper sulfate without water, we call it as anhydrous copper sulfate. Anhydrous copper sulfate will not be having color. If you are adding few drops of water into that, it will be colored. Okay, yeah. Why? It will be turning immediately into CuSO4 dot 5H2O. Okay, water has come along with it, no? So it will be, yeah, turning it into blue in color. So this test can be used as a test for water, no? Okay, yeah. The liquid you are adding to anhydrous copper sulfate should be water. Then only it will be turning the color into blue. So hydrated copper sulfate will be blue in color. Okay, yeah. And anhydrous copper sulfate will not be having any color. So if you are adding few drops of water into that, yeah, what will happen? Again, it will be turning into blue. Then hydrated ferrous sulfate. What is the color? Yeah, it will be green in color. If you are heating that, yeah, it will become anhydrous ferrous sulfate. Okay, yeah. What is the color of anhydrous ferrous sulfate? Yeah, it is Colorless. Okay, if you are adding water, again it will be turning green. Okay, you can just memorize a picture and this will help you in that analytical chemistry chapter also related to your practical part. Now, let's see some board questions related to what we have discussed. Okay, yeah. So, if you are doing this kind of questions, no, you will become more and more confident. Okay, read that. Write the observation of the reaction when ammonia reacts with copper oxide. They are not asking the balanced chemical equation, but they are asking the observation of the reaction. Okay, so somewhere, if you are not remembering the product of the reaction, okay, somewhere you can write and see. We don't want to by heart it. Ammonia with copper oxide. Ammonia is a reducing agent. Hydrogen will be given to copper oxide. Oxygen will take that. So definitely one product obtained will be water. And hydrogen is going away with oxygen. So what will be the other product obtained? Nitrogen. Okay, yeah. Then now from copper oxide, oxygen is going away with, along with hydrogen. So what will be the other product? Yeah, it will be copper. Got it, no? Yeah, we could easily predict the product of the reaction, but they are asking the observation of the reaction. Okay, yeah. What is the observation? You can say that, yeah, black colored copper oxide will be turning into reddish brown. Correct, no? Okay, yeah, that is the observation of the reaction. Only one observation they have asked, so you can write like that. Now see this one. Write a balanced chemical equation when lead oxide reacts with ammonia. We didn't discuss that. Okay, write and see what will happen. Lead oxide, PbO, and then ammonia I will write over here. What will happen? Hydrogen will be given to oxygen. Why? Ammonia is a reducing agent. So, one product obtained will be water. And what will be the other product obtained? Yeah, that will be nitrogen. And see, oxygen is going along with hydrogen. Yeah, what will be the other product obtained? That will be lead. Okay. I forgot to tell you one more point related to lead oxide ammonia reaction also. They will be asking what will be the observation of the reaction. Okay, yeah. So I have kept a picture over here. See what is the color of lead oxide? Lead oxide is yellow in color. Okay, yeah, it is yellow in color. If you are passing dry ammonia gas over hot lead oxide, what will happen? Yeah, it will be turning into the metallic lead. Correct, no? So what will be the color of metallic lead? It will be turning gray. You can write the observation like that. So along with copper oxide ammonia reaction, you can remember this also, this point also. You can just note it down. Now see this one. What will be the product obtained when ammonia reacts with bleaching powder? So most of some of the textbooks are related to ICSE books that they haven't given this question. Okay, yeah, they haven't discussed anything related to that. But sometimes, for brilliant children like you, you may get questions like this. Okay, yeah. So teacher wants to test whether you are learning something extra. So that time you can expect this kind of questions. Okay. So only thing to be remembered is that what is the formula of bleaching powder? Write along with me. Yeah, bleaching powder is calcium oxychloride, CaOCl2. Got it? Yeah. Now, treat it with ammonia gas. What will happen? See, reducing agent, no? Yeah, so hydrogen will be given to calcium oxychloride. So hydrogen will go and combine with oxygen. So one product obtained will be definitely water. Correct, no? Okay, yeah. What will be the other product of the reaction? Oxygen is going along with hydrogen, no? So what is remaining? Calcium and chlorine together. Yeah, you will be getting calcium chloride. Right? Yeah, from ammonia, hydrogen went away. Then who is remaining? Yeah, you will be getting nitrogen gas. Easily we predicted the product of the reaction. Okay, yeah. Now you can pause the video and try to balance the chemical equation. Yeah, see, I also will do that. Nitrogen is 1 over here and here nitrogen is 2. I am putting a 2 over here. Totally hydrogen became, here it became 6. Okay, yeah. So here it is only 2. I put a 3 in front of this one. Now oxygen became 3 over here. So here only 1 oxygen, 3 over here. Now calcium will become 3 over here. So I put 3 over here. Then I think chlorine automatically it became correct. Even nitrogen also correct. All are happy. Okay, yeah. We predicted the product of the reaction also and then we balanced it also easily. Got it, no? Yes. Now see this one. Okay, yeah. The last question. The gaseous products obtained when ammonia gas is passed over heated copper oxide were condensed. Okay. Now, the resulting colorless liquid is added to anhydrous copper sulfate. What will be the observation of the reaction? So, like that you can just memorize. Okay, yeah. See, here only we have written it. Okay, yeah. Ammonia is reacting with copper oxide. What will be the gaseous product obtained? Water vapor will be formed, nitrogen will be formed. Now only we discuss that. Okay, yeah. Nitrogen, yeah, will remain as such, but like a water, easily it will be, water vapor will be condensing into liquid water. Then what we will do? Yeah, we will take anhydrous copper sulfate. What is the color of anhydrous copper sulfate? It doesn't have any color. Okay, yeah. Heroine is not with the hero. That is the reason it is colorless. If you are adding little bit of water into that, what will happen? Yeah, it will be getting converted into, yes, colored copper sulfate. Okay, yeah, or hydrated copper sulfate, CuSO4.5H2O. So how to write the observation of the reaction? Yeah, the condensed liquid when added to anhydrous copper sulfate, it will be turning into bluish in color. Okay, due to the formation of hydrated copper sulfate. So this is a test for water also. Clear now? We have discussed all the questions related to the reducing property of ammonia. Yeah, keep on working hard. Okay, thanks for watching. See you in the next video.